In Chapter 14, Section 2, we'll look at limits and continuity. So this is multivariate, so we have multiple variables in a given function, and it's going to be pretty similar to what we taught you in Calc 1 is how to evaluate a limit. How you evaluate a limit is you just plug in the limit, plug in the numbers. So if I've got two letters and they're approaching two different numbers, just plug those numbers in. So we're just going to say, okay, let x approach 5. So everywhere I see an x, I'm going to replace it with 5. Then it says, okay, y is approaching 4. So everywhere I see a y, we're going to plug in 4. Okay, so we substitute in and we're going to get 5 squared for the x squared, y, which is going to be 4 cubed, then minus that x cubed becomes 5 cubed, that y squared becomes 4 squared, that 2x becomes 2 times 5 plus 4 times y, but y is also 4, and then we have to evaluate all that. So let me actually type in these numbers, 4 and 4, and if you evaluate that, you get, so when you evaluate this properly using PEMDAS, powers first, then multiplication, and then subtraction and addition, you should get negative 374. Okay, find the limit if it exists. So we're going to have the limit as x and y both approach 1, 2 respectively of 5x to the third minus x squared y squared. We're just going to plug in 1 for all x's and 2 for all y's. So we should get, the limit nomenclature goes away. So once I replace these letters with numbers, I don't need LIM anymore. So this is going to be 5 times 1 cubed minus 1 squared times 2 squared. This is just 5, this is just 4. So the whole thing is just 1. Pretty simple. Okay, so that's problem 2. Problem 3, find the limit if it exists. If it doesn't exist, write DNE does not exist. So we have limit triple variable xyz approaching the point 3, 0, 1 of the function e to the negative xy sine of pi z over 2. Okay, so we're going to replace x with 3, y with 0, z with 1. So we're going to get e to the negative 3 times y, which is 0, times sine of pi times z, which is 1, all over 2. This gives us e to the 0 times sine of pi over 2. E to the 0 is 1. Sine of pi over 2, if you look at unit circle, sine of pi over 2 is also 1, so this equals 1 again. Okay, problem 4, we have the limit as xy approaches the origin, 0, 0, of the function x4 minus 6y squared over x squared plus 3y squared. Now, when you plug in 0, everything's going to go away, and this would be 0 over 0. So we have to see how we handle that. So because we can't divide by 0, we're going to get that this limit does not exist. So you'll type in the box, does not exist. Okay, now just looking at the next problem. It's x, y, and z. It's approaching the origin 0, 0, 0. So every letter is going to go to 0. Now if you look at that, every term has a letter in it, which means every term is going to go to 0, which means we're going to get divide by 0 again. So we're going to say does not exist. Okay, 6, determine the set of points at which the function is continuous. Well, it's continuous as long as ex minus y does not equal 5. So let's solve for that. So it's going to be continuous as long as the denominator 5 plus e to the x minus y does not equal 0. So what we do is we set it equal to 0 and we solve to figure out, okay, well, when would this equal 0? So we're going to say let 5 plus e to the x minus y equal 0. And we will take e to the x minus y equals minus 5. The only way to solve for this would be to take a natural log of both sides. Oops. So to undo e, you take a natural log of e. So what that does is it cancels the e function. So on the left you have x minus y. But on the right you have the natural log of a negative number. Now we learned in Calc 1 or probably even college algebra, if you have the natural log of any x, x has to be bigger than 0. So this right here does not exist. But that doesn't mean the answer does not exist. What this means is this denominator can never be 0. So this will never be 0. Which means that the function will be continuous on the entire domain. Okay, problem 7, determine the set of points at which the function is continuous. So e x squared y, there's no equals e to the x squared y plus square root of x plus y to the 6th. Okay, this function is always continuous. So e, there's no number you can pick. E to the 0 is 1. E to a negative number is some negative value. Is actually not even a negative value. It's a positive value because e to the negative number is just 1 over e to that positive power. So this is always continuous. So this function we don't even have to consider. This is continuous as long as x plus y to the 6th is greater than or equal to 0. So as long as that is true, this function will be continuous. So y to the 6th power is always positive. Okay, so with that even power, even negative numbers will be become positive. So the only way this could become negative is if x is somehow is a negative value larger than y6. So this only runs into a problem if negative x is somehow bigger than y to the 6th. So the way we would say that is x has to be, so let's see how they want us to do it, larger than or equal to, and then in this case we would have to have negative y to the 6th. I believe that's what they're looking for there. Yep, so they actually went the other way than I did. So instead of moving the x over, they went from here and they moved the y6 over. So they said x bigger than or equal to negative y6. When it moves across, this inequality becomes negative. Okay, that's problem 7. Problem 8, determine the set of points at which the function is continuous. Same idea. So everything inside of that has to be positive or equal to 0. So we have 2x plus 9y plus z. Well, we just have to force all of this to be bigger than equal to 0. And they're leaving z over here. So z has to be bigger than or equal to minus 2x minus 9y. So we would say z is bigger or equal than minus 2x minus 9y. Okay, in problem 9, same idea. In fact, it's using something I just explained, natural log. So we have g of xy is the natural log of x squared plus y squared minus 14. Well, the natural log of anything has to be strictly bigger than 0. So we're going to make this argument of natural log strictly greater than 0. And notice they have 14 on one side, so this is x squared plus y squared has to be bigger than 14. So we just have to type that. X raised to the second plus y raised to the second has to be strictly greater than, be careful here, 14. You can't let it equal 14, because then the thing would be 0, and natural log is undefined at 0. Okay, last problem. Determine the set of points at which the function is continuous. So it says x squared y cubed over 2x squared plus y squared if xy is not equal to 0. Notice 0, 0 is the only point. I'm going to have to be careful when I say that. Would it be? I believe it's the only point that would cause this to be 0, and 1 everywhere else. So just glancing at this, I do not believe that this function has any problems. And I am incorrect. So let me see why. Okay, I did jump the gun on that one a little bit. So it is defined everywhere, but maybe not continuous. So the only way that this could be continuous is if this function has the same value at this point 0, 0. So clearly, if you plug in 0 for both letters into this function, you get 0 divided by 0. So what happens is this function at the origin, so right here at the origin, this function, so it is defined at the origin to be 1. So let me do it in green. But this function, as it's doing whatever it's doing, so it's over here doing something, it's approaching 0 over 0 as I go there. But what happens is at this, it has a hole, and then it jumps up to, I should have done green here. So this is green, green, green. Then at the origin, it has a hole, and it jumps up here, and then it keeps doing whatever it's doing. So that is not continuous right there. So what we say is, it is continuous as long as xy does not equal that origin point. Okay, so that will be the correct answer there, and that will conclude chapter 14, section 2.